Hey, welcome back to ClearSpot. Every solar operator knows the truth. Running a solar plant is not simple, it's not automated, and it's definitely not effortless. Behind every kilowatt hour delivered to the grid, there are alarms, failures, dispatch decisions, schedules, weather shifts, grid signals, and honestly 100 moving parts. And yet, the industry still tries to manage all of this using static rules, outdated SCADA thresholds, and manual decision-making. But here's the reality. SCADA can't solve these challenges. Manual coordination can't solve them. Traditional automation can't solve them. But AI agents can. And today we're going deep into 5 real-world operational challenges that solar operators face every single day, and how autonomous agents solve them in ways nothing else can. Challenge 1. False alarm overload. The problem every operator knows and quietly hates. SCADA uses static thresholds. If a value crosses a line, send alert, but solar plants don't operate in static conditions. They operate in context. Temperature changes with weather, voltage changes with maintenance, output changes with irradiance. SCADA doesn't understand context, it only understands numbers. You can lower thresholds, but then you miss real issues. You can raise thresholds, but then you drown in noise. Either way, you lose. Imagine a 50 megawatt site where operators spend about 20 hours each week just investigating noise. With labor costs at $50 per hour, that adds up to an annual wasted cost of $52,000. But agents can cut this by 80 to 90%. That means savings of $40,000 to $47,000 per site every year. That's 6 hours per week of operator time, returned every week. Now let's talk about the second big challenge, unplanned downtime. Here's how most maintenance still works. Failure leads to detection, then dispatch, followed by diagnosis, and finally repair. The total downtime, usually between 6 and 12 hours. On a 10 megawatt farm, that's about $2,400 in lost revenue for every event. But honestly, the worst part is that almost all of these failures give early warning signs. You just don't see them. So, how do agents help? Well, they track dozens of microscopic indicators like temperature deltas, voltage ripple patterns, vibration changes, efficiency drops, thermal drift, weather-normalized performance, and inverter switching behavior. Then these patterns are compared with thousands of historical failure curves. This is how AI can, spot trouble before it becomes a costly problem. So let's take a 50 megawatt farm as an example. If you have, say, 15 failures each year, and each one causes about 8 hours of downtime, that's 120 hours lost annually. That translates to lost revenue of $168,000 every year. Now, with agents in place, you can prevent about 80% of those failures. Your remaining loss drops to just $33,600. That's a savings of $134,400 every year. And honestly, that's just downtime avoided. You also steer clear of catastrophic secondary damage, which can be even more costly. Now, let's talk about challenge number 3, multi-site coordination. In this scenario, everything feels urgent, and everything conflicts. Imagine having 10 sites, but only 3 maintenance crews and 2 cleaning crews, with all your parts sitting in just one warehouse. The weather keeps changing, failures keep popping up, and performance is always shifting. This isn't just about scheduling. This is really a 15-dimensional optimization problem. Picture this. It's Monday morning, and the agent is evaluating all sites in parallel. Site A needs cleaning on Tuesday. Site B has an inverter failure. Site C is scheduled for maintenance tomorrow. Site D is running at 8% underperformance. Site E is expecting a dust storm on Thursday. Crew 1 and Crew 2 are free, while Crew 3 is already en route. The agent crunches the numbers in seconds. Site B is top priority, so Crew 2 gets dispatched there. The agent combines Site B and Site C into a single trip, saving 2 hours of travel time. It recommends cleaning Site E right away to avoid losses from the dust storm. Site A's cleaning gets pushed to Thursday since rain is in the forecast. Site D is deferred as it's low urgency. And Crew 3, they just continue as planned. Dust storm prevention $8,000 saved. Downtime minimization, $2,000 saved. Travel reduction, $500 saved. Optimized scheduling, $1,500 saved. Total weekly value, $12,000. Annual value, $600,000. Manual scheduling can't compete with algorithmic optimization. Portfolio scale efficiency is only possible with agents. Challenge 4, grid curtailment. The grid operator sends a message, reduce output by 40% within 10 seconds. You must decide which strings to curtail, optimize for revenue, protect equipment, consider battery state, preserve thermal balance, and respond instantly. That's impossible manually. And SCADA only executes commands. It doesn't choose the right ones. SCADA approach, curtail everything equally. Agent approach, curtail hot strings more, protect shaded strings, shift 5% to battery, reduce inverter stress, and plan for rapid ramp-up. Agents evaluate real-time performance, thermal states, degradation states, shading patterns, revenue versus curtailment cost, and storage availability, all in just milliseconds. Typically with uniform curtailment, the annual loss is around $60,000. But when you use an agent-optimized approach, that loss drops to $42,000 a year. That's a savings of $18,000 every year. And on top of that, you avoid penalties that can range from $1,000 to $5,000 per event. Challenge number 5, pattern recognition across time. This is often the silent killer of solar performance. Your performance ratio might drop from 84% to 83, then 82, 80, and eventually 78%. It's a slow decline, barely noticeable at first, but honestly, extremely costly. For a 50-megawatt farm, a 6% loss can mean $126,000 gone each year. The agent reviews multiple data streams and comes to a conclusion. Soiling is increasing due to reduced rainfall, and performance is dropping by 1.5% each month. The recommendation is to increase cleaning to every other week. The cost for this is $12,000 a year, but the recovery is a whopping $198,000 in revenue, a return on investment of 16.5 times.
Soiling detection alone can impact between $50,000 and $150,000. Inverter trending issues range from $20,000 to $60,000, and bypass diode problems can cost anywhere from $30,000 to $100,000. Altogether, the total annual impact adds up to between $100,000 and $310,000. Like, share, and subscribe for more solar insights. ClearSpot, smart device, smarter decisions.